Well, the clouds are back, and it seems like it's either everything or nothing situation. It's either clear and blue or gray overcast. And this is all stratus associated with the tropical moisture return. And let's take a look at the surface map and see where that's coming from. I figure today we'll look at the Aviation Weather Center plots. They've got some good surface data on their page. And what do we see here? Remember yesterday we were under southerly flow and there was some sort of front up in Oklahoma retreating northward. And what we've seen here is it looks like some cold air building in from the northeast, and that's with that Hudson Bay vortex pattern pushing a little cold air down into the Great Lakes, the Midwest, and the lower Mississippi River Valley. So that front has moved southeast through much of East Texas, and out around San Antonio and Austin, it's still warm, still got that southerly flow coming up from the Gulf. And you notice that the marginal VFR corresponds pretty closely to where that front is located. Since it is May, let's check out what's happening in the Panhandle. Well, we know the front is right in that area, so let's look at the Texas Tech Mesonet plots. And it's a little bit hard to read because of that color scheme they're using, but I do see northeast winds up to the Cap Rock around Childress, and boy, that really is hard to read. But I'm going to probably go with a front maybe right in there. Okay, so that could be a boundary later on this evening, and of course down in the warm sector we have to check for a dry line, and that's way out west. And that's going to be in that area, triple point around Vega, extending right down the New Mexico-Texas border. Okay, looking at the GFS thickness and pressure, this is a good way to get a first glance at what's happening in the U.S. I see that things are active out there in the southern Rockies. Band of cold air advection right there, that's going to follow a cold front. I don't know if it's there or maybe it's up in here. It's hard to tell. But anyway, it is there in New Mexico and Colorado. That extends up to a low in Montana, and probably a warm front trailing up into Ontario like that. Also, we've got a cold front moving into Texas, and that's what we looked at there on the Aviation Weather Center chart. Cold air advection coming in to eastern Texas and Louisiana, helping to trigger a few showers and storms. Probably a warm front offshore like that. There's the remains of Arthur. There's our 1030 millibar high, pumping in cold air into the Midwest and the Ohio River Valley, all the way to Texas. And then we have an upper level low right there across the northern Rockies. That's probably what's triggering a lot of that convection there, steep lapse rates, and residual moisture helping to support that shower and even some snow shower activity. All right, let's take a look and see how the surface chart is put together. There we have it, the surface chart. Matches up very well with what we saw in the GFS there. Triple point in the Vega area right down through the West Texas counties. And we can see that cold air filtering into Dallas, Shreveport, and almost to New Orleans. Well, not much to be said about all this. It's pretty self-explanatory. And we'll just take a quick peek up to the north. And you can see that next batch of cold air trying to move down. It's probably going to be heading for the Great Lakes. Not sure how much progress it's going to make, but it will be something to watch up there. Another thing I thought was pretty impressive was up here on the western shores of James Bay, 77 degrees there, contrasting with very cold conditions up to the north. So that shows you some of the temperature contrasts you can get up in that area. And I wouldn't be surprised to see some strong storms up along this cold front. Of course, depending on what the atmosphere is doing. Now let's take a look at things out in the Great Plains. For that, we're going to need to look at the high-resolution rapid refresh. When you don't have anything to look at this early in the day, I think a good plot to start with is dew points and winds. Because here we can see the dry line. Let me advance this up to the current time. That's going to be about right now. So pretty obvious where that dry line is. That matches up well with the surface data. And we can also see that warm front. That's probably going to be running something like that. And there we've got that pooling of moisture back in there behind the warm front with that easterly flow there. So yeah, that's a little wedge of 70s dew points coming up into northwest Texas. Let's see what the patterns are going to do over the next... Oh, okay. Yeah, thunderstorms. See those little outflow pools from developing storms? That's going to be in that upslope air along the front, and probably some further down the dry line, which looks like it has pushed eastward. So the boundaries are kind of like that. And we went from this to this. So the triple point has kind of moved down the dry line boundary. Now I would expect that these storms here would probably depart into some of the cooler air. We need to look at that air because those storms may become less and less rooted in the boundary layer. These here have better potential. And let's see what happens over the next 6 to 12 hours. I see numerous cells, a lot of outflow pools being generated. Those show up very well with dew point because, you know, you're bringing dry air down to the surface. And they start losing some definition, but I can see a lot of cold pool generation around San Angelo and Abilene. So possibly, yeah, and here's some more of it. So it looks like, yeah, here's probably a small MCS coming together, maybe a series of them. This is going to be at 11 o'clock to midnight. And whenever you have a boundary that's oriented northwest-southeast with the upper level flow like that, that means you're going to have storms that are going to tend to track down the boundary. See the upper level winds? Got some mid-level northwesterlies in there. They are out of the southwest aloft, so things are probably a little bit indeterminate, but you can see the Corfiti vectors are pointing towards the southeast. That's what these are right here. That gives you an idea of your MCS propagation, and that's going to be right down that warm front. So that can keep those storms going. All right, I've advanced the high-resolution rapid refresh up to 17Z, so we now have our newer run, and that'll kind of let me see the changes since we had the 12Z run earlier. Yep, you can see that warm front firming up. You can see the convergence coming together from Lubbock up towards the area west of Amarillo. And I can see one outflow pool there already. So storms going up west of Lubbock and west of Amarillo, around Hereford and maybe south to about Littleton. That's going to be about 6 p.m. or so. The outflow pools will join together and we'll see upscale growth into a little MCS there along the Caprock, northeast of Lubbock, southeast of Amarillo. So another thing that I want to show you is how to read these moisture plots. You can see starting out at the beginning of the day, the moist air mass looks very uniform. I can see out here kind of a weakness, and that's due to mixing of the boundary layer. Probably some dry air aloft being mixed down to the surface, but you see overall it has kind of a uniform appearance when you go from one point to another. And of course back here is the dry line, and there's the front. So what happens when we go forward? Let me bring this all the way to when the storms are going. And you can see going along the axis of the moisture advection like that. It looks very smooth in this area. So that's a relatively undisturbed air mass. You see the colors change pretty significantly, but that's just a change in the color scheme. Going this way, though, that looks like a crossover into the cool air mass. See that right there? That's the warm front boundary. But as we go further north, things get very noisy, and you can see bubbles. And that's where we hit the outflow pool. Now this spot here, I don't know if that's a thunderstorm outflow pool or just mixed dry air to the surface, but we can click a sounding on that and see what's going on. And that just looks like maybe some dry air that's come down to the surface. Doesn't look like any convection going on. But that close to the thunderstorm complex, that does give us a pretty good proximity sounding. And we can see that there's probably a lot of dry air that's been mixed out, and that's feeding into these storms further to the northwest. So a lot of problems with moisture. Let's look at that air mass and also look at the wind profile. We can see weak winds all the way up. Little anvil level ventilation there. But even in the 9 to 12 kilometer band, that's really not enough to make much of an impact. So if we were to get supercells, they'd probably be in the HP part of the spectrum. Now what I'm going to do is I'm going to switch over. Keep in mind that our warm front boundary goes like that, and you can see that the moisture is a little bit better north of that warm front. See how we go from, let me give you a cursor readout. See how we go from dew points around 50 to 57, 56, 59, 62. Then we cross over and we get up to 67, 70, 69. That's something to keep in mind there. So let's switch over to the precip. Remember, the front is right there. Bring that up to this evening. So the better parcels are probably up to the north as long as they don't get elevated. And the LCLs will be quite a bit lower north of that front. You can see that thin layer of good dew points, and that's helping to give us some really good parcels. See that really good cape there? And that easterly flow is also helping us stretch out the hodograph. See some good turning in the winds there. You can see the SRHs are looking pretty decent. The cape is up there, 3,000 to 4,000. So those are some pretty decent soundings there. The problem is the wind profile is a little bit weak. And we can see that the 9 to 12 kilometer wind flow is putting us into mostly HP territory. And due to the very strong easterly component with very weak upper level winds, this is going to mean slow moving storms. You can see the right motion vector there showing east at 10. And the normal cell motion that you'll see initially is going to be probably to the northeast at about 15 to 20 knots. So severe movers slowing down and moving slowly to the east. We can see that the 4 to 6 kilometer winds are pretty decent, and also the 0 through 2 kilometer winds, very good, about 30 knots there. Keep in mind that this is all storm relative winds. So a lot of good parameters here for rotating storms. And that's why I would probably favor that cell there. Probably going around Plainview, and I could see that propagating rapidly to the southeast, trying to get into some of that better moisture. See, that's about 0Z. The other problem, though, is outflow. Outflow is a big problem. This time of year, when you have dry air aloft, when you have weak upper level shear with poor anvil ventilation, and we can see that the D-cape is way up there, 1633. So these are going to be outflow dominant, I think. I think as soon as the storm starts cranking up and rotating, I think it's going to get undercut by outflow pretty quick. And that in turn means a very rapid propagation further towards the warm air. And so we're probably going to see a cluster of cells or an MCS propagating down that warm front after dark. Now this storm complex, this is more entraining the dry air, and you can see the proximity soundings out ahead of that. That's not very good. Poor moisture, 55 dew point, and getting worse as you go aloft. So these are going to be elevated. So you see the big difference that you get between one storm region and another. Now these storms further up north, they could do something. If you wanted to avoid the crowds, that could be a option on a day like this. You can see the moisture is, not quite as good as it is down south. A little more capping there. However, the photographs are, decent. But the same problem, outflow of storms. And there's a quick check of our situation. Got the warm front about like that. Some of the stratus and stratocumulus north of that boundary. Dry line somewhere in there. And we can see the first specks of convection going up west of Amarillo, west of Hereford, and down towards the Clovis area. That should gradually increase in coverage and form up into storms between Amarillo and Lubbock, and we should see a little action there this evening. All right, that's all I have for this evening. Let's get this uploaded and available to you guys. I do want to thank our new supporter, Jep Williamson. Thank you for supporting the webcast, and we do depend a lot on your support. Hopefully that'll get us to another equipment upgrade here this summer. I thought it'd be fun to go into some of the old files and show you what this webcast looked like 5 years ago. So let's take it back to 2015 and look at some bits and pieces. So thanks for watching, and we'll see you tomorrow. June 27th, 2015. You can see a storm there about halfway between Houston and Dallas. This is the sounding for Fort Worth, Texas for this morning. This is from a radiosonde released from the surface, goes up to about 15-20 miles, and it gives us temperature and moisture with height. And what we see here is that there's a whole lot of moisture up to about 15,000 feet. Above that, it's pretty dry. That's a pretty good depth of tropical air.